Hi, my name is Juan Angeles. I'm a computer engineering senior here at San Francisco State University. Today I want to show you my final project for Engineering 844 Embedded Systems. Now, I've designed a Micromouse that has motion control as well as collision avoidance in real time. Now, just to give a brief overview of its architecture, this is based off the TM4C123 TIBA launchpad. On the front and sides, we have 3 infrared sensors from Sharp. On the back, we have a dual motor control based off the L298 H bridge. And on the bottom here, we have your standard TT DC motors, as well as 4 AA batteries in a plastic enclosure. And these are your standard little robot wheels. Now, all of this is enclosed in this chassis from Adafruit, which was perfect because it already has perforated holes of standard size that fit these sensors. So the way it works is the mouse is constantly getting data at a set timer or sampling rate. Now, when the data goes into the microcontroller, is directly sent to memory via DMA. And when the memory buffers are full, the data is sent to the processor and analyzed there or processed there. Now, the raw data from these sensors is nonlinear. So first we have to linearize it for us to make decisions with it. And after doing so, then is sent through an FSM, which dictates the motion that the mouse is going into. So for example, it can go forward, it can turn left or right, or it can make a full turn. So yeah, so this is my project. I hope you enjoy it, and the code will be in the link below. Thank you.